Hello, Acids and Bases, Class 10, Lecture 3. What do all acids and all bases have in common? General point is acids means generally they release protons, H plus ions, and bases means they release OH minus ions, or you can say they can accept H plus ions. So H plus is called proton. Proton acceptors you can call bases. Proton releasing substances you can call acids. Similarly, few substances they can release OH minus also like NaOH, KOH. So what is mentioned in NCERT book? Let's see. In section 2.1 we have seen that all acids have similar chemical properties. What leads to this similarity in properties? We see in activity 2.3 that all acids generate hydrogen gas. 2.1.3. Okay, all acids generate hydrogen gas and react with metals. So hydrogen seems to be common to all acids. Let us perform an activity to investigate whether all compounds containing hydrogen are acidic. All compounds containing hydrogen are acidic is very important. See, HCl is hydrochloric acid, H2SO4 is sulfuric acid, HNO3 is nitric acid. Good. Methane, carbon is also having hydrogen, but this is not an acid. H2S, okay, H2O, all these if you consider, they are not so good acids, or you can say they are not acids. Methane is not an acid, ammonia is not an acid. Water and H2S are very weak acids. So what we can say is, if they contain hydrogen, it doesn't mean that they are acids. See, let us see. Take solutions of glucose, alcohol, hydrochloric acid, sulfuric acid, etc. Fix two nails on a cork and place the cork in 100 ml beaker. Connect the nails to the two terminals of a 6-volt battery through a bulb and a switch as shown in figure 2.3. This one. Now pour some dilute HCl in the beaker and switch on the current. Repeat with dilute sulfuric acid. What do you observe? Repeat the experiment separately with glucose and alcohol solutions. What do you observe now? Does the bulb glow in all cases? First two cases it will glow. Next two cases it won't glow. The reason is very simple. The glucose and alcohol are not acids, even though they contain alcohol means generally we take C2H5OH beta, and glucose is C6H12O6. They have hydrogen, but they do not release any H plus ions. So they are not acids, simply you can say. So what are acids? HCl and H2SO4 type. So if a substance contains hydrogen, it doesn't mean that it is an acid. Fine. See, this is the experiment. Let us see conclusion. What is given here? The bulb will start glowing in the case of acids as shown in figure 2.3, but you will observe that glucose and alcohol solutions do not conduct electricity. Glowing of the bulb indicates that there is flow of electric current through the solution. The electric current is carried through the acidic solution by ions. Such kind of ions are not formed in case of glucose and alcohol, but in case of HCl and H2SO4, H plus ions are formed. So because of the formation of these ions, there is flow of electricity. Electric current is carried. Fine. So in acids cases, the light will glow, not in case of glucose and alcohol. Acids contain H plus ions as cation and anions such as Cl minus in HCl, NO3 minus in HNO3, SO4 minus in H2SO4, CH3COO minus in CH3COH, right? Acetic acid, hydrogen chloride, nitric acid, sulfuric acid, 2H plus and SO4 minus 2. Correct, na? Since the cation present in acids is H plus, this suggests that acids produce hydrogen ions, H plus ions, in solution, which are responsible for their acidic properties. So the reason for the acidic property is H plus ions. Repeat the same activity using alkalis such as sodium hydroxide, calcium hydroxide. What can you conclude from the results of this activity? You can say same bulb will glow in case of sodium hydroxide, calcium hydroxide, and definitely Generally OH containing compounds are generally bases, right? So we don't find much kind of compounds like what we are taking glucose and such kind of things. So we are talking about OH minus ions. Generally OH minus means that that is a base generally. Okay, generally I repeat, because BOH taken thrice, you can say OH is there, so it is base, but it is actually H3BO3. H3BO3 is boric acid. So I mentioned in general. Fine. So bases also will give the light to glow, that condition. Okay. So OH minus ion releasing substances are called bases. H plus ion releasing substances are called acids. 2.2.1, what happens to an acid or a base in a water solution? Nothing will happen. What happens? It will become dilute. Strong acid will become strong, concentrated acid will become dilute acid. Strong concentrated base will become strong dilute base. Okay. Do acids produce ions only in aqueous solution? Let us test this. Okay. See, dropper containing concentrated H2SO4. This is all okay. Test tube, sodium chloride, and what we kept here, a pair of tongue, test tube, litmus paper. Very simple. Let us see. Take about 1 gram of solid NaCl in a clean and dry test tube and set up the apparatus as shown in figure 2.4. Add some concentrated sulfuric acid to the test tube. What do you observe? Is there a gas coming out of the delivery tube? Test the gas evolved successively with dry and wet blue litmus paper. In which case does the litmus paper change color? On the basis of the above, what do you infer about the acidic character of dry HCl gas and HCl solution? For me, it's a note to teachers. If the climate is very humid, you will have to pass the gas produced through a GAR tube, drying tube containing calcium chloride to dry the gas. Otherwise, the moisture will also participate. Chalo. What is mentioned here? Let us see. This experiment suggests that hydrogen ions in HCl are produced in the presence of water. The separation of H plus ions from HCl molecules cannot occur in the absence of water. So water role is to break H plus and Cl minus. H plus and Cl minus are going to be produced. HCl plus H2O gives us H3O plus and Cl minus. Hydrogen ions cannot exist alone. Okay, now only H plus won't exist. So this will join with water to form H3O plus like that, hydronium. But they exist after combining with water molecules. Thus, hydrogen ions must always be shown as H plus AQ, aqueous solution, or simply you can say H3O plus. H plus water, H3O plus. Okay, fine, good job. We have seen that acids give H3O plus or H plus ions in water. Let us see what happens when a base is dissolved in water. Same thing, NaOH, Na plus and OH minus ions. So the substances which release H plus ions in water is called, H plus ion in water is called acid. OH minus ions in water is called base. The substances which release H plus ions in water is acid. The substances which release OH minus in water is base. KOH, K plus OH minus, MgOH taken twice, Mg plus 2 and OH minus. Bases generate hydroxide ions in water. Bases which are soluble in water are called alkalis. Bases which are soluble in water are called alkalis. It's another word we can use. All bases do not dissolve in water. An alkali is a base that dissolves in water. Just now we were discussing that line. They are soapy to touch, bitter and corrosive. Never taste or touch them as they may cause harm. Acids are bases. You should not taste. Okay. Which of the bases in the table 2.1 are alkalis? 2.1 gone long back. I think KOH, NaOH, calcium hydroxide, magnesium hydroxide, and ammonium hydroxide. All are soluble in water, so all you can call. Now, as we have identified that all acids generate H plus ions and all bases generate OH minus ions, we can view the neutralization reaction as follows. Actually, beta, this H plus ions and OH minus concept is very old concept. So whatever the substances they release H plus ions are acids, no doubt. But even though if they don't release, they can be called as acids, like carbon dioxide. Just now we were discussing non-metal oxides, like metal oxides. Okay, now metal oxides, sodium oxide, magnesium oxide, calcium oxide. When you are taking, they can be considered as bases. Okay, but here the definition is H plus ions. If they are released, that is acid. OH minus ions generated, that is base. So acid plus base is equal salt and water. For example, HCl plus NaOH gives rise to NaCl plus water. Or simply you can say H plus from acid, OH minus from base gives you water. H plus OH minus is equals to water. Let us see what is involved when water is mixed with an acid or base. Nothing happens. I told you, concentration decreases. That's all. Warning sign displayed on containers containing concentrated acids and bases, right? Take 10 ml of water in a beaker, add few drops of concentrated sulfuric acid to it, and swirl the beaker slowly. Touch the base of the beaker. Is there a change in temperature? Is this an exothermic or endothermic process? Repeat the above activity with sodium hydroxide pellets and record your observation. Generally dilution is exothermic, means energy will be released and the test tube will become little hot. Chalo, let us see what is mentioned here. The process of dissolving an acid or a base in water is highly exothermic. Care must be taken while mixing concentrated nitric acid or sulfuric acid with water. Okay, now however this point has come, now I will tell you. For example, this is the bowl with water and you are adding concentrated H2SO4. Okay, now how to add concentrated sulfuric acid to water? Don't add water to sulfuric acid, that's very dangerous. Okay, now add slowly, very slowly, small amounts of concentrated sulfuric acid to large amounts of water. This is the right way, this is the wrong way. Don't add water to a big amount of sulfuric acid. Danger it is. The acid must always be added slowly to water with constant stirring. See, the acid must always be added slowly to water with constant stirring. If water is added to a concentrated acid, the heat generated may cause the mixture to splash out and cause burns. Got it, na? So we should add acid to water, not water to acid. Looks meaning is same, but remember, huge amount of water to that small amount of sulfuric acid. That's good. Not huge amount of acid and small amount of water. That's dangerous. Fine. The glass container may also break due to excessive local heating. Look out for the warning signs shown in figure 2.5 on the can of concentrated sulfuric acid and on the bottle of sodium hydroxide pellets. In both the cases, same thing happens. Mixing an acid or base with water results in decrease in the concentration of ions H3O plus and OH minus per unit volume. Such a process is called dilution and the acid or the base is said to be diluted. As I told you, when you are adding water, it is called diluted. Questions? We'll go to 2.3 in another video. This part we'll see now. Why do HCl, HNO3, etc. show acidic characters in aqueous solutions? Because they release H plus ions. While solutions of compounds like alcohol and glucose do not show acidic character because they cannot release H plus ions. Why does an aqueous solution of an acid conduct electricity? Due to H plus ions. Why does dry HCl gas not change the color in the dry litmus paper? Dry HCl is not an acid. HCl is an acid in water. Because in water only HCl can break to give H plus and Cl minus. Otherwise HCl bond is strong. In dry state this bond won't break. So in dry state it is not an acid. While diluting the acid, why it is recommended that the acid should be added to water and not water to the acid? Because the reaction is going to be highly exothermic. So to the large amount of water, small amount of acid is to be added, not reverse. Because heat burns and even glass beaker test tube will even, that is also, then there is a possibility of breaking that particular apparatus also. So no, very big no. you need to add acid to large amount of water, not water to acid. How is the concentration of hydronium ions H3O plus affected when a solution of an acid is diluted? Nothing. Number of ions per unit area decreases. That is only called dilution. Okay, because see, 100 ml of acid is there, let us say. So all H plus ions water present, they are present in 100 ml. Now to this you are adding 1000 ml of water. 1 liter water you added. Now the total volume will become 1100, but the number of H plus ions will remain same. Earlier, let us say if 100 H plus ions are there, 100 H plus ions are present in 100 ml. But now the same 100 H plus ions should present in 1100 ml. So definitely number of H plus ions per unit volume decreases. That is only called diluted. How is the concentration of hydroxide ions affected when excess of base is dissolved in a solution of sodium hydroxide? How is the concentration of hydroxide ions affected when excess of base is dissolved in a solution of sodium hydroxide? Already sodium hydroxide solution is there, means NaOH, Na plus and OH minus ions are there, OH minus ions are there. Now again you are adding OH minus ions, excess base when you are adding. So obviously now the reverse case better. For example, 1000 ml contains, let us say, 100 OH minus ions for easy understanding purpose. And again you are adding some 500 OH minus ions. So definitely what happens? Volume is same, into the same 1000 ml you added extra. So concentration increases. That means you are doing concentrated. Okay, now diluted is converted to concentrated. Question number in 5th, concentrated to dilute. Question number 6, dilute to concentrated. Okay. We'll meet in next class to discuss about 2.3. Thank you.